So I think most people are just curious about WebAssembly and seeing how you might want to do it. Correct me if I'm wrong. Like you can unmute your mics because now it's like totally free for all. You can speak. We can't see your faces if you don't turn on the cams. So yeah. So you can feel free to like maybe share like what you want to get out of today. This is a very special session and it's very focused. So you should take advantage of it, especially if you plan to use WebAssembly and maybe not even just explore, but really use it. Hi, Sarah.
So I guess I shouldn't be on the live stream and on the Zoom at the same time, right?
Why not?
Yeah, you can be on both. I've got the Zoom running on 2 computers, and I've got the YouTube live stream open on a computer, so I've got like everything monitored. 2 computers, and I've got the YouTube live stream open on a computer, so I've got like everything monitored.
I think you should mute one of them.
Yeah, I mute YouTube. Plus that there's maybe a 3-second lag on the YouTube one.
Right. I just turned on the live stream, so this live stream should be seeing what the gallery view for everyone here.
If my mic is on, you might sporadically hear cat meowings, so I apologize in advance.
Meow. I just fed my cat anyway, so yeah.
Is your cat out of the room? Is he banned from the room?
I don't know.
Not in the room.
Mine is here, so.
Ah, okay.
Take a photo.
Toodles.
Mine is actually up there.
Your cat's up there?
Oh, yeah,
Maybe I should drag mine out. But once he's out, he doesn't like hide the room.
Too dark to be seen.
Man's eating. I was kind of serious actually about the eating thing, but I think no one took me seriously.
I've got a drink.
What's that? Hibiscus?
No.
Red wine.
Blackberry and blackcurrant cordial.
You mean Ribena?
Basically, yes. It's just in a fancier bottle than Ribena, so it's not Ribena.
Artisanal Ribena.
Hi, actually, I'm also having my dinner right in front of my computer right now.
I don't see your cameo, Vijay.
Oh, right, hi. My dinner is here right now. I just gonna show my messy room. Yeah, I just gonna stop the video.
That's fine. I totally chose like the whitest wall in my house. I thought about this, yo.
So for my bit of open mic, I listened to a podcast yesterday, which was quite interesting about HTTP 3, which is, there are some implementations out there already, and some of it's standardized, I think, and some of it's still being standardized. But I thought it was pretty interesting, so I just shared it in the chat room there. If you go into you tap on the video, you click participants, and then I posted in. Oh, okay, I've sent it privately. I have to try again. Okay, thanks. I will send it to everyone.
Alright, so we're just getting ready.
So yeah, HTTP 3 could be faster. There was something about security with when you make an HTTPS request. The first time you connect, when you make an SSL, when you're securely connecting to a server, it doesn't know which domain you want the first time, at the moment. But I think HTTP 3 is offering some way to say, hey, to say which domain you're accessing without everybody being able to see it. So it will be encrypted. But I think it doesn't work on the first time you connect. I think what it's saying is the first time you connect, it will send you back a load of, hey, we've got all of these SSL certificates. So next time, if you want any of these domains, you know how to encrypt your request. So it's kind of half secure. That's on the open source podcast.
I see it. Maybe it's not a great idea. Hi, Sandy.
Sup, peoples?
If anyone is judging me for eating chocolate for dinner, I just exercised.
Nom 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 nom.
Cancels out. Good job.
Nom 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 nom.
That's the only purpose of exercising, right?
That's the point of exercise, right? So we can eat chocolate later.
Remember.
That too.
Oh, now I'm tempted to go down and get some more chocolate. I had mine earlier.
I have artisanal chocolate. Basically a fancy honeycomb bar. Very good. What are you having, Sarah?
Noodles. Sorry, I have 3 meetups on the same at the same time, so I'm gonna mute myself.
Oh, okay. Does anyone have any like particular questions or things about WebAssembly you want to like bring forward to Aaron first, so he can take note of it in his talk?
Could you please mention about OASI, WebAssembly System Interface? I just found out about it today, so I want to learn more about it.
I can touch on it briefly. I will be honest that I haven't looked too much into WASI itself. There's other folks on my team that are very much invested in it. So I know some of the high levels from what they've talked about, but not like the really the implementation level stuff with WASI. I haven't got into that yet. I've been more just looking at where WebAssembly fits into like the web dev toolchain and that sort of stuff.
Okay, that's fine. At least there's something to hear about it. Yeah. Because today, literally, I just found out about it.
Getting ready for the podcast.
What's the possibility on it?
Getting ready for the recording for the talk.js.
Can you repeat yourself then?
Today, I just found out about WASI and
So
just wondering what's the possibility of
the laptop where we're doing
its usages.
Zoom video call on. So the Zoom video call, and now I have an external screen. So the external screen is.
Does anyone have any other parts that you wanna have highlighted?
The full screen version of the Zoom video call, and on my left I have.
Why haven't you guys used it? Because from the poll, like
which is doing the recording, so it's
only
actually the recording and streaming.
2 people are planning to use it. One is already using it.
I
And
guess
No.
I would have a question. How do we use it? What can I do with it now?
And is it worth the trouble?
So you can see.
Not trouble. I mean,
I have one microphone here, which is meant for Zoom.
I have some thoughts about WebAssembly, more work related. Because I'm just interested because I previously experimented with WebAssembly, creating a WebAssembly file using Golang. Yeah, I think that's back with I forgot which Golang version, but more recent versions. But thinking how to use WebAssembly to say with DRM. With for example, DRM protected audio or video playback.
Cool. Yeah, that's definitely one of the use cases for WebAssembly is dealing with some of that stuff that can be naturally more challenging in just raw JavaScript. And that's one of the reasons that I think it's quite an interesting, exciting technology is the sandboxing nature of it, and the potential to reuse stuff from a back end onto the front end.
Yeah, I like the idea of using libraries from other languages. That would be a nice to unify all these different languages. We can share our code more easily.
We can make browser pain everyone's pain.
Yeah.
That also reminds me that if you guys used this Figma, this tool, this service called Figma. So
Yeah.
apparently, yeah, Figma is also using WebAssembly.
Oh.
Yeah, I shared the link to their blog. So apparently they've been using WebAssembly for quite a while.
Interesting. I haven't come across Figma.
For design wireframes, isn't it?
Yeah, yeah.
Wow, Peter.
Do you know why they use WebAssembly on Figma rather than JavaScript?
I think primarily they're aiming at faster load time.
Yeah, it's very asset heavy, honestly.
Yeah, I think because they will have to, because since they are drawing tool, they have to handle a lot of vector, assume like vector graphics and probably some raster graphics. So probably they need a speed. They need to a very speedy site for that. Yeah, in terms of
and then you can offload that stuff from CPU because WebAssembly, off main thread, because WebAssembly doesn't run in the main thread like JavaScript does. So if it's doing anything particularly long running, like CPU intensive, you run that risk of doing blocking with inside of the browser. And then if you're trying to do repaint and stuff like that, yeah, it can become problematic.
Yeah.
Have your designers or whoever is using Figma figured out how to version?
How to what version?
How to version the mockup? No, this is very off topic. That's because previously my designer gave me like version 47, version 48, version 49.
How to version? We usually just duplicate the artboard and create it side by side, right? Or create a new page.
So really version.
Pages.
Then you put the version number on.
Yeah, I'll just define the name of the artboard. I create a page that's archive and throw the not used one in there.
I would love it if they got snapshots. Then you can like go back and then different amounts.
there is a version history or version 3 lah, but
Oh, yeah?
not really used much. Like if you want to go step back in time.
Okay. That'd be good. Okay, I guess we can start because it's already 7:32. So for those of us that are not muted, we should mute ourselves. So not much introduction for today. Really, this is just Singapore.js talk gone online. And thanks to Engineers.SG for hosting us, as well as for like setting up everything, so we didn't have to think about anything. So that was really awesome. And thanks to Aaron for agreeing to do this talk. He's based in Sydney right now, and it's really late for him. So we will have our usual open mic at the end of the session. So today is like there's no like really fixed time. Like we usually end by 9. So today is pretty much just like Aaron giving his talk, and after that, please feel free to ask all your questions. This is a great opportunity. I mean, to also like type things out, so that's really clear for everyone, and also like comfortable for you if you like it. So like do take advantage of this virtual talk. Yeah. Don't have any other things. Please stay respectful. And a reminder from Engineers.SG that this is being live streamed on their channel. So yeah, don't get them in trouble. Yeah, so without further ado, I guess all of us should turn off our videos. Or if you want to keep it on, that's fine too. If you have no issues. But just mute our mics. Yeah, so I'll hand it over to Aaron.
Cool. If people want to ask questions, feel free to jump in and ask questions at any point in time, or type them out in the chat, either Zoom or YouTube. I am monitoring those on a second computer. But I've also turned on live captioning on the slides. So if I'm speaking too fast or anything like that, hopefully you can catch up with the live captioning. Otherwise, just shout out and say, can you slow down, or could you cover something again if it wasn't coming across clearly enough? Because I've got enough time that we can spend tonight, and I will promise I won't fall asleep while presenting. Well, at least I'm going to try not fall asleep while presenting. It's been a long day, but we'll get through this. But thank you for having me. My name's Aaron. I work for Microsoft. I'm part of the developer relations team, the cloud developer advocate at Microsoft. You can find me online on Twitter at Slace. I blog at aaron-powell.com, and my GitHub is Aaron Powell. So it's mostly my name, except for Twitter. If you want to find me, if you want to send me a DM, ask questions, or anything like that. I've got some links also at the end of some content that I've written around WebAssembly specifically, and kind of to follow up the talk that I want to cover off today. But we're here to talk about WebAssembly, so let's dive straight in. This is WebAssembly. Well, this most specifically is the WebAssembly text language. And this is what you write when you're writing WebAssembly. Let me just break down precisely what's happening in this code. First off, we're creating a module, and inside of that module, we're going to import a function from an object called console, and the property of that we're unpacking is log. I'm just aliasing that locally into the WASM file as a variable named $log. So that's the dollars after the func declaration about halfway through that line. And then this function will take 2 parameters. They're both going to be int32s or i32 types. And that's going to be the 2 arguments that the function that's provided to me from our host for WebAssembly, that's what it'll expect. The next thing I'm going to be importing into this WebAssembly module is I'm going to import some memory. The memory is going to be 1 kilobyte. So it's going to be 1 memory page, which is 64 kilobits. And that's the minimum amount of memory that I can import for the WebAssembly module. Next, I'm going to put some data into memory. I'm pushing that onto the stack at position 0. So that's what int.const 0 is. So stack position 0 in our memory, pushing on some data, and it's going to be a string containing the word hi. And then finally, this module is going to export a function of its own. That function is going to be called write hi, and it's going to, when that function is executed by the WebAssembly host, it will pop two variables onto the stack. They're both in32s. The first one is going to be 0. The second one is going to be 2. And they will represent the memory starting position and the memory ending position that we want to be able to read out of. And then finally, we're going to call that function that was passed in from our WebAssembly host called $log. And by pushing those two things into the stack, they are then going to be passed as the arguments to the function that's being called. Everyone still with me? Hopefully everyone's still with me. Now, onto the JavaScript side of things, because JavaScript is the most common host that we've got for WebAssembly. Someone did ask before about WASM, and that's another way that we can host WebAssembly, and I'll talk a bit more about that at the end. Or if I don't, remind me to talk a bit about that at the end. But in JavaScript, we need to create some things to make sure that we can execute this. I've realized that the live captioning is sitting a bit over the top of the slides. Fortunately, I don't think I can actually move the position of that, but I'll explain what's kind of behind. Okay, so the first thing that we're doing, oops, let me go back, is we're going to create our memory in our JavaScript host for our WebAssembly application. This is using the WebAssembly memory method or object, and saying the initial size of this is a 1 page in size, so it's 64 kilobits, and I'm just assigning that to a local variable called mem. I'm then creating a function called log, which will take 2 arguments, an offset and a length. So this is the function that we're actually going to be passing across to WebAssembly when we're invoking it. This function will receive those. I expect that they're going to be numbers passed in, but because JavaScript is an inherently untyped language, we don't know that they're numbers. We just assume they're going to be numbers. But inside of that, we're then going to use the memory that was provided, read the buffer of that memory, and then turn that into a unsigned 8-bit integer array. And that will start at the offset of what was passed in and the length. And we'll grab the number of bytes out of that to the length that we are specifying, and that was getting passed in. This gives me a byte array that I pass to a text decoder. Oh, looks like my live captioning might have crashed. Well, that was a fun experiment. Nope, we're back. So we're using a text decoder, a UTF-8, to decode those bytes into a string, and then we call console.log, which writes it out to the console that's available for this JavaScript host. Finally, we create an imports object that we have a property called console, which has a property called log, and we're passing in some JavaScript references, which is going to be the memory that we created at the top of this file. And then the very final thing, which unfortunately you can't quite see from the caption that sits in front, but behind that, actually, I think I can hide that briefly. Hey, I can briefly hide that. So what we can see there is that we're using WebAssembly.instantiate streaming. So this is an asynchronous function that expects a stream, generally, so a stream that is returned from a promise, and generally something like a fetch is done to download the WebAssembly binary from some remote source. In this case, it's just running locally and side by side with this JavaScript file. So we use fetch to download that. We pass in the import object we created before. And then once we've instantiated our WebAssembly virtual machine, we can then use the WebAssembly instance, grab the exports of that, and invoke the write hi function. Let's just get the live captioning back on. Okay, so if you're like me and you've just seen like 5 minutes of explanation of that, you're probably thinking that this is utterly confusing. Like, I've just shown something that doesn't look like pretty much most programming languages I've ever worked with, at least, and then a whole bunch of kind of complex JavaScript to create memory and functions that, you know, dealing with buffers. And I don't think before I'd worked with WebAssembly I'd ever used text, like the text decoder or an unsigned int array or anything like that. Those things were just not what I would use in JavaScript. But this is the future, as we're being told. This is what WebAssembly is going to be a useful tool when we go ahead and building web applications. Okay, well, but maybe let's actually take a step back, because I dove right into how WebAssembly works, and showed off some code initially, which I can appreciate is probably a little bit complex if you haven't come at WebAssembly previously. So understanding precisely what the point of all that code is, why it exists, and even what's the point of WebAssembly. Let's step back and rewind and look a bit at some of that stuff. So first off, what is WebAssembly? Now, in around about 2013, Mozilla put forward this recommendation for a specification in which they called WASM.js, which was short for Assembly.js. It was a strict subset of the JavaScript runtime that was designed as a compilation target from other programming languages, predominantly C and C++. You weren't writing WASM.js yourself, you were compiling to WASM.js. And because of the way that they were, the restrictions that were put in WASM.js and the way you were expected to compile to it, browsers could do a lot of pre-optimizations around the language itself. It didn't have the loose typing to the same degree that JavaScript has, because it was predominantly working with arrays and buffers and predefined known types. We weren't using objects and glorified hashtags, which is predominantly what we do in JavaScript. And this allowed people to build really high performance applications, particularly around graphic heavy centric applications. It was some ports of things like the Unity engine the Unreal Engine to WASM.js, and it was pretty playable. It wasn't as fast as running it on bare metal on a laptop or a desktop or a console system, but it was still pretty decent, particularly compared to what else you could do in the browser at that point in time. But WebAssembly essentially evolved out of WASM.js. They realized that there was a need for this kind of low-level programming within inside of the browser. So an effort was created to define a specification for that, and that specification would become WebAssembly. And the goal was to create a stack-based virtual machine that would exist within inside of a JavaScript runtime. Predominantly runs in, obviously, most JavaScript runtimes are running in the browser, but you've also got Node.js. Node.js has support for running WebAssembly, and then now there's look at things like WASI as ways to run WebAssembly outside of JavaScript runtimes necessarily. But because it's now a stack-based virtual machine, or a VM in and of itself, it is able to get a lot more consistency across the implementations within browsers. No longer do we have this differentiating, what is the underlying hardware that's available in a mobile device versus a laptop versus a tablet versus a television or anything like that. The VM host just abstracts all of that away for us. And because it's now running as a compiled binary rather than just plain old JavaScript or a strict subset of JavaScript, we're able to optimize for it even better and and remove things like jitting and stuff like that you would traditionally have in a JavaScript application. And because we now own the virtual machine where our WebAssembly applications run, we can do things like control the amount of memory that's available for that. So where you might have had applications that could have memory leaks or exploits against the amount of memory that they're using and crash machines because you just have runaway memory consumption, the WebAssembly binary, so the WebAssembly VM is constrained, and we avoid some of those potential attack vectors. But they also made a decision that WebAssembly would only support a really strict set of data types. In fact, it really only supports numbers. There's some caveats to that, but it's predominantly numbers. We don't have objects the same way as we would think of them in JavaScript. We don't have strings the same way as we'd think of them in JavaScript. We don't have functions quite the same as we'd think of them in JavaScript. This is where the memory becomes important. If we want to use something more complex than a number, we end up having to rely on the memory and pushing things into memory to deal with that. Now, WebAssembly isn't designed as the thing that you're predominantly going to write. WebAssembly text language, that is the language of WebAssembly, but you're not necessarily going to write that. Instead, you're going to write some sort of a higher level language and compile down. Similar with WASM.js, where we were using, the most common tool for that was LLVM to do a compilation down to WASM.js. We're going to use some sort of high level tool to compile languages down, because let's be honest, the language that I showed at the start, it's pretty foreign to most of us and probably not the ideal thing that we want to try and write all the time. That would get kind of cumbersome. But if you are a Lisp programmer, you probably are very familiar with having to put parentheses on the end of things. So maybe it is actually something that you would quite like to run. But when I've started playing around with WebAssembly, I had this notion that, well, has anyone ever sat down and gone, you know what my website needs? You know what I need in the browser? I need more C++. No, I don't think that's ever been like a major demand of the applications that I've ever worked on, that we're like, yes, C++, if only I could be running C++ in the browser. That would solve all of these problems. So what's the point of WebAssembly then? And if we're building applications as JavaScript developers, what is the point of WebAssembly? Now, one thing that I want to make clear is that WebAssembly isn't intended as a replacement for JavaScript. There's plenty of things that you can do with WebAssembly that are much better to do in WebAssembly than we would do in plain old JavaScript. But there's a lot of things that JavaScript is actually really good at. Things like working with the DOM. You actually don't have the concept of the DOM available in WebAssembly, at least not in its current form. I believe that there's stuff in the spec that they're working on for future iterations that will expose the DOM in a more rich format. But at this point in time, the WebAssembly that's available inside of pretty much all the browsers doesn't have access to the DOM. You have to do a bunch of stuff to make that accessible. But some languages, well, they do actually seem to be going down the route of trying to make it a full-blown replacement. Things like Golang or Blazor in .NET, they're trying to be a complete replacement for running any form of JavaScript. And I'm not entirely convinced that that is going to be the best way long term for how we can build applications using WebAssembly. Because like I said, there's things that JavaScript is really good at. And I think we need to remember that, particularly as JavaScript developers, that we don't want to just completely replace a tool just for the sake of replacing it. Now, there's a bunch of new terminology that WebAssembly introduces into the mix that I'll just touch on so that we all understand precisely what it is as we go into some demos shortly. The first is the module. The module was that thing that was the very top of the code base that we looked at right back at the start of this talk. And a module is essentially a WebAssembly binary. It's the thing that we're creating. It's the thing that we're running. It's the output from some compiler. It's predominantly, it's a binary file. And inside of that, we have things that live. So the module is the thing that you're going to use to create your virtual machine, and you'll end up with a running instance of a module. Now, an instance is your VM. Now, you can have multiple WebAssembly VMs running at the same time. You can create multiple WebAssembly VMs from the same module as well. So if you've got a bit of code that you wanted to start up multiple times, you could do that. I'm not quite sure if that would be a good idea, but you definitely can run the same module multiple times. More importantly, though, because you can run multiple WebAssembly virtual machines, multiple instances, you can actually do a bunch of things to make them communicate with each other as well. So you could write some stuff in like Golang, some in Rust, and they could talk to each other using the WebAssembly host. Next, we have our memory. The memory is something that is like a shared bridge between our WebAssembly host and our WebAssembly instance. Now, if our host is JavaScript, we create this as an array buffer, and we pass that array buffer into the instance when it started. That was part of that import object that I created. But because it's an array buffer that is essentially owned by the host, by JavaScript in this case, I can pass that into multiple instances. So that's where if we wanted to be able to share values across multiple instances, we could use the memory buffer there. Now, this is useful for storing values. So strings, complex objects, we can put all of those because we can represent them as binaries that we can put into this array buffer. Sorry, bytes that we can put into this array buffer. So so that's how we can put more complex data structures than just ints and floats and stuff like that. But then we also have tables. Tables are kind of like memory in WebAssembly, but they're designed to pass in function references rather than value references. So if I've got a function inside of my JavaScript host that I want to make available to my WebAssembly host, my WebAssembly instance, I create a table. I put a reference to that function in the table, and then I pass that table into my instance when I start it, and then I can access that inside of my WebAssembly application. I can then use tables in multiple instances, so I can share functions. My WebAssembly application can push functions into tables, and that's how our host can access them. That's how we can also have functions that get called across from different WebAssembly instances. So both memory and table can be adjusted in size on the fly. They have to be, you have to have a minimum size for them. I forget what it is for table off the top of my head, but memory is 64 kilobits. But you can grow that out to, I think, basically the limit of memory available to the host. Browsers will have a constraint on the amount of memory that they can allocate to WebAssembly, but that's probably going to vary browser engine to browser engine and across devices. So like device will have a lot less. But that's not to say that you're a pretty crazy web application. Okay. Do we understand a bit about what WebAssembly is and some of the terminology that WebAssembly has behind it? But why would we want to be using WebAssembly in the applications that we're building? Well, one of the really core things that I think WebAssembly is good for is sandboxing. And I touched on this a bit before. The idea of being able to create a memory-controlled, security sandboxed environment that we can execute some code in. We know that with a JavaScript application, whenever we run third-party JavaScript on our page, there is the potential that that third-party JavaScript could do something nefarious to the rest of our code base. And we don't want that to happen. But when something is running inside of a WebAssembly sandbox, that's a lot harder to achieve because the code isn't being interpreted. It's pre-compiled. It's not. There's no JIT running anymore to do anything. So we have a lot more of a controlled security sandbox there. This could be really good if we're doing cryptography in our application. We don't necessarily want our cryptographic algorithms exposed, or we don't want them potentially available for corruption. So we could run them inside of a sandbox. And that means that we have a lot more confidence that they're running successfully. Maybe we want to share some code between our client and server. Let's say that you're doing something like image manipulation, and you found a great image library that you want to use, but it's written in Golang. Well, you can then find a port of that to JavaScript, or you can find one with comparable features that runs in JavaScript, and you can run that in the browser, but then you've still it's still not the same. You can't guarantee that what someone is seeing in the UI is going to be the same as what's getting output by the back end. But what if we could actually just use that same code? We could use that WebAssembly, that Golang module, both client and server, so that we can see real time, give that feedback to the user of what's they're going to have happen to an image that they've uploaded, but then actually do the proper processing down the track. Or maybe we want to do some complex mathematical operations, work with numbers in some way, shape, or form. We know that JavaScript has some issues with the way that it can deal with numbers based off of the way that it implements floating points. And this can mean that we can have some odd edge cases, particularly if we're doing things that are very precision sensitive, or we're doing things that require a lot of complex computations around mathematics. So maybe we put that in, we write that in a language that's better designed for mathematical operations. Something like a data science language like Python or F#. We could do that, and we could compile that down and then just call it as though it's another library within inside of our application. And this is also where kind of things like video games are also looking at WebAssembly as a core technology, because they do a lot of stuff with numbers, with processing like vectors and stuff like that, and they can do that with more confidence in languages other than JavaScript. All right. So we want to build something with WebAssembly now. But what does that look like as a JavaScript developer? How do we go about building an application that leverages WebAssembly? Well, first off, we need to look at a whole bunch of language options that we've got. And we could do C or C++. We could use Rust, or we could do .NET in like C# or F#. We could use the WebAssembly text language. Like, you could actually write that if you wanted, because it compiles down to the binary format. It's probably going to be a lot more complex because it doesn't have high-level constructs like strings, really, or complex objects. So it can be painful. We could use Golang. We could use assembly script. Assembly script I find is quite interesting because it's a variation of TypeScript. So you are actually kind of writing JavaScript to a degree, but then compiling it to WebAssembly to run with inside of JavaScript. And I'm like, oh, my head hurts. Why are people doing that? But these are a bunch of different options. I've played around with C#, F#, and Golang as ways of building WebAssembly. Next up, we work out, well, we got to compile our WebAssembly into a WebAssembly binary somehow. Well, how do we do compilations in JavaScript at the moment? We use Webpack or Parcel or a myriad of other tools, but Webpack is definitely doing a good job of winning in the wars of building out our build and compilation steps inside of JavaScript. So I tend to go with Webpack, and then you pick your front end framework of choice. I go with React because it's the one I like to work with, but you could use Vue or Angular or, heaven forbid, Vanilla.js. Like, actually work with the DOM directly? That sounds like a crazy notion. All right. So that's enough slides. Let's have a look at how we can bring all of this together. And I have a sample application. So I've written a little bit of Golang. It's a very exciting application that I've got here. If you're not a Golang developer, don't worry. I'm not here to convince you to write Golang or anything like that. But what I've done is I've created an application that will be, it pulls down a markdown file from a GitHub repo that contains a list of conferences that are happening in Australia. I then have a function, I then have a Golang module that I've written called Markdown Tools, which processes that file, extracts out the conferences from the other stuff that's there into a data structure that I use within inside of my application. And then this is just this is a console application, so this will just dump it out to terminal. So let's have a look at that. Pop up a terminal here. Let's start off by doing go build. There we go. So it's just compiled out my application, and let's just do /app to run this application. And it's very exciting. If we scroll up, you'll see that there's a whole bunch of conferences. It's just dumped it out as JSON. I could then pipe this through like I don't have it. I used to have it in my my backstack. Let's try this /app. I used to have it in my backstack to be able to do like JQ, and I can't remember the syntax of JQ off the top of my head, but I could find something in there using, because it's now just a JSON payload. But this might be great for certain use cases. It's a server application that I'm running, or I'm interacting with the terminal. But you know what? I actually want to run this in the browser, because as cool as terminals are, the readability of this is not great. As you can see, I can't remember the syntax of JQ to work out how to query it, to find stuff. So let's turn that into a web application. And here's one I've created earlier. It's a React application. Actually, I'm going to just do an npm start on this because it'll take a. Oh, yep.
Could you zoom in a bit and make the font a bit larger for us? Thank you.
Yes. Oh, sorry. I've got it on my large monitor, and I forget that my resolution is probably quite large relative to what people are running at home and watching on the live share. Yeah. All right. That was the one thing I forgot to check beforehand. Cool. Did that save? Save settings. Oh, is that better or is that too big now?
Okay, good for me.
I'm on 13-inch.
Cool. We'll leave it at 30 point. That's that'll do. But I'll scroll around the code so we can understand it. Okay, cool. My application is starting up. Let's open up a browser. What's kind of fun is I've actually got the slides still running in the background, and the live captioning is still running on the slides. And I can see that on my second monitor. I can see the live captioning, but no one else can. Whoops. Did I start a browser? I'm sure I just started a browser. No, maybe not. Ah, there it is. Eventually, we will get the internets up. Oh, there we go. Oh, come on. There's nothing like live demos. Okay, port 9000, because that'll kick off the Webpack compile in the background. We'll see that running momentarily. Okay, now, so the application will show the markdown as, the data that's come back will come back just as raw JSON from my Golang application. And then I'm going to turn that into a React application and put that into like some tabulated data so that I can do sorting and filtering, and all that kind of stuff will then happen in client side. We have a app.js, app.tsx. That's right. I wrote this in TypeScript just because I wanted to see how far I could push my integration between the two things of JavaScript and WebAssembly. I'm just going to scroll up a moment. I do enjoy how slow my computer has started to become. Let's just check something. Got to. Come on. I've had to swap onto battery so I could charge my other laptop, but I think it's running. There we go. It was not running at top performance, but we'll put that back up, and then hopefully things will start running a little bit faster, or not. Now, here we are. Wrong window. I have so many windows open. Here we go. Okay, excellent. So it's a React application. I've got some things in here like React Router and the kind of usual stuff that you would have for a React single page application. Because I'm using TypeScript, I've then got some type definitions around to define the way state works and things like that. But the interesting stuff happens then in this module called fetch events. We'll go down and have a look at how that exposes me a function called download here. We scroll down to component did mount. I actually wrote this before hooks was out. If I was to go back and update this code, I would totally be doing hooks everywhere because hooks are the awesomes. And it's the only way to write React these days. But I have this download year function. I pass in the label for the year. I pass in the URL for the markdown file that's relative for that year. And then that is going to return me an async function, or returns me a promise. When that's successful, I will then set state and update add those years to state, and then it does some stuff to make sure that it displays. We'll scroll down to our render method, which then has a menu, links, etc. But the important one is the home route, which then takes in a list of all those years and stuff like that. The components themselves are not particularly interesting. What I want to focus on is this fetch events, because that's where stuff starts getting properly interesting. I will just have a look at the way the download year works. First up, So it's an async function. So we use fetch to download that URL. We get the raw text out of that URL. Sorry, out of that response. So that's the markdown contents. And then I am passing that across to this dev events.parse markdown. Now that function, we'll see where that comes from in just a moment. And then that gives me something that comes back as a string. I then turn that into JSON, which I then do some iterations of to make into a data structure that I want to use in my application. But this dev events.parse markdown, where does that come from? That comes from this very first line here at the top. Import dev events from dev events.go. That doesn't sound like a JavaScript file or a TypeScript file. Dev events.go is, unsurprisingly, a Golang file. Here we're using the Markdown Tools library that I've created, which is the same one that our console application used. I have a Golang module that I've written that does some interop with Webpack and a Webpack build step that I've got. I'll show you that in a moment. And what it does is exposes a function called parse markdown. This function, it will receive a string. So we unpack that from the arguments that get passed in. It then uses my markdown tools to parse the markdown into the year data structure, then converts that into JSON and then returns that as a string. I use the GoBridge, which is the thing that I've written in for my Webpack interop, to register a callback called parse markdown. So register a function parse markdown and give it the reference parse markdown to that function on line 11. And what that does is it basically sets up so that Webpack can be used as a thing to orchestrate the compilation of Golang. So if we go to our Webpack config, scroll down a little bit, we can see that we are now supporting Go as an extension to Resolve. And then if we find Go, we use a loader called Golang WASM async loader, which is just available on NPM. And that's kind of how things all come together, is that transparently, this all then gets exposed as a bunch of JavaScript or TypeScript in my case that I can work with. I've done some stuff to define the types, because there's no way I can actually determine the types without having to have written them myself. But still, this all kind of works. And if we come back to our browser, ta-da! This is the application running. I'll bring up the developer tools. Oops, undock those this morning. So let me just redock those. Over here, that. Let's just reload. See, all these HTTP requests are being made. And then if we have a look at the sources, pop that open, we'll see that there is WebAssembly, and that's the stuff that's existed in here. And we actually get a bunch of fun stuff, like the GoBridge appears in here and stuff like that. If we come into, I think it's the application tab now, we can find the WebAssembly, or maybe it's, I'm sure they've lit it up inside of, I'm sure it was lit up in here with inside of the Edge Dev Tools, but maybe not. Okay. Yeah, I've forgotten where it is, if it's available. But this is, like I said, this is now a React application. So if I came across to the React Dev Tools, which component, sorry, I can see them there. There's a table. It's got some stuff in it. I've got a menu up here. I can jump into the 2020 table. I can say what events are happening with JavaScript in them. Cool. There's 2 events happening in Australia with JavaScript. I only care about the ones in New South Wales. And this is all now happening client side, because I've got that data. But the thing that I needed to do to get that data, to process it, to turn it into a JSON payload that I can consume in my React application, was maybe too complex to write in JavaScript, or I had it written already in another language, and I've now just compiled that down and we run it here. So that's how we can combine it all together. And hopefully that all makes a little bit of sense. So just to kind of wrap up this part of the talk, sorry, excuse me. WebAssembly, like it's here, it's in all evergreen browsers. So Edge on the Chromium runtime, Chrome obviously, Safari, Firefox, and anything that runs as a Chromium base. So Opera, Brave, stuff like that. They all support WebAssembly. On mobile, it can be a little bit more hit and miss on mobile, primarily because of the amount of memory required. But I know that Android does support it in Chrome. I'm pretty confident that it works in iOS, but I don't have an iOS device myself, so I haven't ever done any testing. But I have run that application that I just had there on my Android device, and it works. It's a little bit slower because it requires more memory. So WebAssembly, like I said, I think the primary use case for it, at least in the sort of things that I foresee myself building, is to sandbox part of my application, whether that's for security requirements, for IP sensitivity, whatever it might be. I can sandbox parts of my application into WebAssembly and make them give me a level of confidence in the way that they're running on the security model around them. The idea of being able to reuse client and server code, I think there's some value in that, particularly if you're doing if your server is in a language like Golang or .NET. I have seen that you can do things like C Python, so compiling Python to C to WebAssembly, and I believe there is a JavaScript approach to doing WebAssembly. I haven't looked into that too much because I haven't been in the Java space for quite a number of years, but I do remember someone talking about it inside of my team. But yeah, that's definitely a good other use case for it. And finally, some languages are better for certain type of workloads than others. I think it's important to be a multi-language programmer these days. Just focusing on one language means that you can miss out on the value that other languages can bring in, whether it's looking at like object-oriented languages next to functional programming languages and using a mix of those two, or whether it's using high-performance languages like Rust or C++ and C for certain workloads, and .NET or Java for others. Kind of combine them together where it's possible. And with WebAssembly, we can actually take advantage of that, and we're no longer just constrained to running JavaScript to run in the browser. We can use other languages and compile them down to run inside of the browser. If you want to learn a bit more, this first URL, aka.ms/learnwasm, that is a short link to a 6-part series that I did on learning WebAssembly. It kind of goes through the process of, I didn't know anything about WebAssembly to start with, to building an application and how to integrate it into a build pipeline with Webpack and all that kind of stuff. So it kind of covers off like each step of the journey that you might go through. And then webassembly.org is the homepage for WebAssembly. It's got a lot of good examples, talks about some of the underlying concepts of WebAssembly, how the language works, how the runtimes work and stuff like that. I learned a lot by diving into that to understand the core building blocks of what WebAssembly is useful for and how you can use it. But that's the core stuff that I wanted to cover off today in my talk. Thanks for having me present at your user group tonight. I'm sad that I wasn't able to come over and do it in person, but I'm glad that we were able to make it a virtual event at the very least. And to just go back to some of the questions that were asked throughout the kind of freeform discussion at the start. So there was a question asked about WASM, which is an approach to running WebAssembly in a more generic host. It's it's something that I'm aware of because I have members of my team that are looking into WASI and to use cases of WASI within inside of Microsoft. But I haven't actually dived too much into it myself. What I do believe it can be compared to is almost like, think of it almost like containerization, Docker and stuff like that. This idea that you can build an application and then run it on a host where everything is really abstracted away. Like the hardware is abstracted away, the operating system is abstracted away. So if you're deploying something into Windows or Mac or Linux, it doesn't matter because it's the WASI host that takes care of the interfacing to the OS and how you need to do those comms. And what that means is that it's a lot easier to create portable applications. And I know that there's some experiments around trying to run WASI with inside of like Kubernetes, so that because it's just like that's just a host at the end of the day. It just tends to predominantly host Docker containers, but that's where it can be useful for. But by being able to be doing things that are like really cross-platform, using WebAssembly as the binary method to ship, it means that we can free ourselves from the way that we're doing cross-platform runtimes at the moment. So that's what I understand about WASI and sort of the role that it might play in the future. I think it's probably too early to say, when that we're going to see that in production or anything like that. But it's something I would keep your eyes out for and think of what it might be useful for. There was another question I saw around databases and file access and stuff like that. So first off, it's going to really depend on where you're hosting your WebAssembly instances. If you're hosting them inside of Node.js, then you can do like a database connection through like the Node runtime, like through a SQL server or like Postgres or Mongo or whatever it might be. But yeah, and there's no reason why you couldn't pull in like the Golang Postgres database connector and then write all of your SQL queries with inside of Golang and then just expose the results back out of a WebAssembly binary. If you're running that in a browser, it does become a little bit more tricky because you've got to think about how do you do the connection through from the browser to your SQL server, or to your database server. And then that requires your database server to be publicly available over the internet, or on your internet if this is just for an internal thing. But then you're starting to think about security ramifications and stuff like that. Are you properly securing the credentials that are used to connect to it? Because they are running the browser, and you are essentially shipping a binary down that someone could decompile and extract information out of. So do you really want to be doing a SQL connection directly from the browser to a SQL database or like a database somewhere? Possibly not. Now, file system is actually quite an interesting one. And I'm going to show off another demo because this was something that I didn't kind of initially realize until I played around a bit more with it. So from a file system standpoint, it's actually quite unusual the way WebAssembly works. So this is my website. I did some work on it over Christmas to add a search component to it. Because my website is actually deployed as a static website. So it's just literally just CSS, HTML, and JavaScript. And hopefully this doesn't fail, but it is working. So I now have search on there. And the search is actually implemented in WebAssembly. Specifically, I am using Blazor and compiling C# and F# to run this application. So this is running a .NET runtime. Then the way the application works, or the way my search indexer works, is that I'm using a search library called Lucene.net, which is it's a search indexer for .NET applications. And it goes out, it downloads a pre-built index that I have of my website, puts it on the file system that the .NET runtime has access to, and then I can do things like, let's do WebAssembly. Do a search for WebAssembly. So here are all the articles that I've written on WebAssembly, but let's do minus F#. So, and this is all like happening on a search index that's running on what it believes to be a file system, but it's not actually a file system. And this is because, like I said, this is running on as a .NET application, so it's running on the .NET runtime, which has the concept of a file system provided to it via Mono and I think it's LLVM. I think under the hood they actually use LLVM as a translation engine. As far as the application is aware, it's on a Unix system. I let this out because I was using like system.io and exploring around on that. And if you do like OS name, it would return Unix. I was like, that's very unusual. I did not expect that to be Unix. Now, what about other platforms? So Golang, it will have the concept of a file system because Golang itself has a concept of a file system. How they represent that, I'm not quite sure. Similarly with Rust and C++ and stuff like that, I don't think they will have the concept of the file system quite the same way. Now, what will become interesting in the future is the way that other browser APIs get exposed through to WebAssembly. There's an API that's being designed at the moment to provide a file system with inside of the browser. Now, this file system is designed to be used with things like progressive web applications. So you could imagine that you're building like a notebook application as a PWA, progressive web application, and you want to save those notes to disk so that you can then hydrate them in future in an offline scenario. So for that, you're going to need access to a file system. And the browser itself doesn't have access to the file system, so it can't write it anywhere other than to local storage or to IndexedDB. Now, if it has access to a file system, it can write them to there, like in a controlled location or a sandbox location or anything like that. But then if that API exists in the browser, there's no reason why you can't expose that through to WebAssembly. And then WebAssembly has the concept of a file system that it can talk to as well. So the different hosts, the different compilation languages that we use, whether it is C++ or C# or CPython or Golang or Rust or whatever, they will have the concept of a file system as a language. How they translate that to working with inside of WebAssembly is going to depend on the way that that language implements its runtime. For Rust and C++ and C, they don't have a runtime per se, so they won't have that that thing there existing. .NET has the runtime, so you are actually starting a .NET. You're actually starting a .NET console application essentially, and that gives you a file system that you can work with. So I've just noticed a couple other questions have come in on the chat, so let me just have a quick scroll through those, or feel free to just unmute yourself and ask the questions as well. So there's a question about so popular use cases for WebAssembly at the moment, and what would be some killer use cases. So a lot of WebAssembly is around like gaming. Gaming is like a really popular use case for WebAssembly at the moment because you can take an application that was written for for console or for desktop and compile those down and run them in the browser at almost comparable performance that you would get for just running them natively on the host. So that's kind of cool because it means that you don't have to have these install processes and stuff like that to get an application there. Another use case I see for Blazor in particular is around replacing intranet applications. So let's say that you've been building an intranet application that it's traditionally like a desktop application or something like that, but you want to be able to now like not just tie yourself to like a particular revision of Windows, and it can only ever run like Windows 7 Service Pack 3. Well, if you ship it as a browser application, that's going to make it a whole lot easier. But we don't necessarily want to turn everyone into JavaScript developers, and that's where something like Blazor fits in. So being able to take those skills that you've got as a developer and build web applications, even if you don't necessarily know a huge amount about building web applications, doesn't mean that I think every application needs to be written in WebAssembly. I said in the going through the slides, I disagree with that notion. JavaScript has a lot of value, and to build a good web application, you should understand the role that the role that JavaScript plays in that, and you should also understand the role that WebAssembly could play in that. So there's another question around what do I think about other languages like Rust as targets for WebAssembly? Now, languages like Rust and C++ and C are possibly better optimized for using use cases in WebAssembly than the likes of .NET or Golang and stuff like that. And the primary reason is because they are sort of like memory uncontrolled. So you control the memory in those applications. In like C++ in particular, you have to create pointers and stuff like that. Because WebAssembly, you have to do your own memory management. When using, say, .NET, we get very used to the fact that it just does garbage collection on our behalf. So, but there's no concept of garbage collection inside of WebAssembly. There's proposals in the spec to add that, but right now that doesn't exist. So they have to do a bunch of stuff that WebAssembly doesn't technically support inside of WebAssembly. So there's a whole bunch of overhead. And this is why, so this search application that I've got showing at the moment, I think it's like 5 or 6 meg. And a few dozen DLLs that you have to download to make this application work. And it's not exactly complex. Like, it's not doing a lot of stuff right now. The Golang application, I think the compilation of that is like 2.5 meg for just the Golang application to run. And all it's doing is parsing Markdown. And that's because these languages, they need to bring a whole bunch of stuff with them. They have to bring their runtime and things like that. Rust, on the other hand, doesn't. Like a minimalistic Rust application to probably do similar to what I've done with the WebAssembly Golang application, you're probably talking about kilobytes in file size, not megabytes, which my Golang version is. And that's because it can just naturally compile down a lot smaller. Now, that's not to say that you can't do better things, more intelligent things with Golang and .NET. I know the .NET team is doing a lot of work to try and reduce size of Blazor applications, and some of that is around trying to work out what code paths need to be executed and remove the ones that don't get executed, so that .NET native side of things. Golang, there is an alternative compiler to the primary Go compiler called TinyGo, which produces a much smaller binary that can run in WebAssembly. Then we're talking hundreds of kilobytes instead of megabytes worth of size for sample applications. But again, you are still a little bit limited. Another question in the chat is, can WebAssembly draw to a browser canvas? The short answer is no. The slightly longer answer is yes, you can, provided you have something that will do the interrupt to the canvas for you. I think I actually have a demo of doing this. Actually, I can find that in search, WebAssembly. Let me have a quick, here we go. Now, let me just check, do I still have this application running? Bear with me one moment, please, while I scroll down. Here it is, running. So this is a Blazor application that draws to canvas. We'll load up in a moment and you can see it. This is where WebAssembly can take a little bit long. And let's draw, we can draw some pretty colors. Whoop. So that's actually drawing on canvas. I'll pop the link to this in the chat, but basically, there's a whole bunch of interrupt that is done in JavaScript to expose the canvas up to WebAssembly or to .NET in this case, and then kind of marshalling back and forth. So there's a bunch of JavaScript that had to be written for this to work. But the actual processing of where the mouse pointer is, the lines that I'm drawing and all that kind of stuff, that's all done inside of .NET. It's just the actual paints to the canvas are then done with inside of JavaScript, because it doesn't, like, the canvas isn't a concept with inside of WebAssembly because the DOM isn't available. Okay, so if I find a Golang program that can process images, could I use that to process images in browser? And how would I pass the image from JS to WebAssembly and back and forth? So yes, you can. You would need to compile that Golang library down to WebAssembly, and then you would have to do some things to expose the appropriate functions from that library to JavaScript, to your host. This is kind of why in the, so if I come over to fetch events here, sorry, not fetch events, dev events. Oops, that's not what I wanted. Dev events. So dev events here, and if I come into Markdown tools, so Markdown tools is this is just a Golang library, and it actually uses a library that I found on GitHub for parsing Markdown. I then just work through the AST of the Markdown that I get back and do some manipulation to it. This file here, this dev events.go, that is exposing a library to my host, and it provides me with a way to interact with that. Now, in the case of an image, you might be you might pass in like a base64 encoded version, encoded string of that image, or maybe you pass in a byte array through memory of that image and stuff like that, and then it can manipulate with that byte array inside of Golang, and then pass it back out as a new byte array or as a new base64 string or whatever it might be, and kind of do that marshal back and forth. So the constructs of objects that you would have in JavaScript, like the image type that we have in JavaScript, you can't pass that directly into WebAssembly because that type doesn't exist. But you can do things more intelligently around like the way that you convert that image into something that can be translated across the bridge. And then the next question is that, is there a standard approach for mapping dependencies between WebAssembly binaries? So if one WASM binary is depending on another, and so on and so forth. So I assume that you're more referring to like the if you had multiple WebAssembly instances running and you wanted to communicate between them, how do you manage all of that? The process is pretty manual. Right? There's no easy way that you can do that management between, just because there's nothing like WebAssembly. The sandbox doesn't know about the other sandboxes. You have to explicitly pass that in. And if one WebAssembly instance expects to be able to call a function that just happens to come from another one, if that function doesn't exist, it'll just crash because it doesn't know that one should be already running. You have to take care of managing all of those. So the question: can we pass references by arguments by reference from JavaScript to WebAssembly? No, because they're running in two separate memory environments. You have to push them into the memory table. So the memory array or a table if it's a function, and then that memory is available inside of JavaScript. So if you do manipulation of that bit of memory inside of your WebAssembly module, and then that memory is then that memory is available inside of JavaScript, and it has to do it like pull that memory back out, turn it back into an object, and work with it. It's not a by ref. It's more like by val as a form of reference passing. Cool. I think I've caught up. Oh, wait, no, another question. So there's a question: if I compile a JS program to WebAssembly, would it still use JS limited precision numbers? think from memory, the number format used by WebAssembly for floating point might actually be IEEE 754 as well. I'd say don't quote me on that, but this has been recorded. It's on YouTube, so I've been quoted at saying that. But there is stuff that it does slightly different with floating points, but I can't remember off the top of my head. But if you were to use assembly scripts, which is essentially JavaScript that's compiling to WebAssembly, maybe you're going to have some restrictions on it. If you are passing floating point numbers up from JavaScript to WebAssembly through the memory arrays, then they start life as JavaScript numbers. So if they lose precision within inside of those, there's potential to that loss of precision is passed across. But I have not done the there's like a 0.1 plus 0.1 whether that equals 0.2. Just to, like that fun one that everyone points at JavaScript and goes, this is why floating point numbers in JavaScript don't work. Yeah, that would be a good experiment for someone to try.
Okay, Aaron, thanks very much for your presentation.
So
My pleasure.
Yeah, thanks a lot for that. That was very interesting. The rest of you guys can feel free to unmute your mics if you prefer to ask casually over voice instead. Any other questions? Like, this is a really great opportunity just to really look into it. So, I mean, like, don't be shy. You're behind your keyboard now, so we can't say anything.
And I'm in another country, remember? So,
oh yeah,
I can't even come and find you and be like, no, why did you ask me that question?
So no questions?
I have another question, if you don't mind. Do
Yep.
you use WASM at Microsoft Cloud at the moment?
Or anywhere else in the organization? Like, where have you seen it being used?
So I know that there are parts of the business that are looking at it a lot more than other parts. I've been on some threads around how we can use WASM in particular scenarios around serverless as one place. There is definite interest around WASI as inside of Microsoft. One of the people on my team, he's a Rust developer, and he's on the compiler team for implementing Rust and WebAssembly. So he's actually very deeply involved with a number of different parts of the organization. First, on the usage of Rust inside of Microsoft, and secondly, on the role that WebAssembly and WASI in particular can play with some of the projects that we're doing.
Mm-hmm.
But as for specific use cases, I probably can't mention any.
Okay.
Cool. Any other questions that anyone might have? Do you imagine you see dominance from certain languages? Or any other reasons? Or like a good support team or?
So I mean, I know the .NET team is very heavily investing in it. They've been working on Blazor for ages, and they've got a commit to ship. I've talked to some customers around using Blazor, and they see it as a way to do things like replace really legacy Silverlight applications. It turns out that there are a number of companies that still run Silverlight in production, and they see WebAssembly as a stepping stone to replacing those. Similarly, for companies that want to do that migration away from traditional desktop applications to progressive web apps, or just normal web applications, they're seeing that WebAssembly can be a way that they don't have to convert their entire dev team into web developers, but they can use web technologies, but and combine that with the skill set of people that are traditionally .NET developers to build internal applications. So I think we'll definitely see a good amount of uptake, or at least a good use case for internal applications for these more complex platforms, such as Blazor. There's a couple of options in the Golang space, and I think that there might be one or two in the Python space for doing that sort of stuff. In terms of like the more, I guess, performance sensitive sorts of applications that we build, things that we might run on mobile devices and whatnot. That's where I think languages like Rust will take off more, because they can produce things that are much smaller in binary size and much more targeted at what they can do. They don't bring over these overheads of runtimes and stuff like that. That search application that I showed on my website, the amount of hacking I had to do to actually make that run inside of a page, rather than just like Blazor taking over the entire application, was quite it was quite painful, just because it's not like the way Blazor is designed is not designed to work that way. Similarly with Golang, it's not really designed to work like I did with that first demo that I had. You can do it. It just requires a whole bunch of additional work. Whereas something like Rust is designed to be used as a library for WebAssembly. It's it's just like a function that you've got running inside of a virtual machine. There's other interesting things like with the Golang version. You've got to do these. There's this thing in Golang called a channel. A channel is a way that you can do bidirectional communication in ways that I don't properly understand, because I'm not really a Golang developer. But you can use channels to basically cause functions to not exit. So you actually have to set up a channel inside of a Golang application that never gets a message put on it, which means that the function never executes. And that's the way that you start a Golang application in WebAssembly, because as soon as it executes through to completion, well, it just garbage collects itself. So if you don't do that, and I actually cover this off in the blog series, if you don't write, there was this arrow C on the end of one of the lines, one of the functions I had. If you don't have that line there, you actually can't execute any code. So just terminate, the VM just terminates. So .NET does a similar thing, because it starts a console application basically. And it's running like a pseudo web server inside of a console application. Whereas, because Rust is designed to be a library, you don't have to do those sorts of hacks.
There's another question asking about the size of the modules.
The answer to that is it depends. It's going to depend on the language. It's going to depend on the amount of code that you've got in there and all that sort of stuff. So the two demos that I showed today, the first one, just to show those tables from the React application, it's a couple of megabytes in size for the Golang binary. No, I don't actually have the output of it somewhere that I can show. It's just all living in memory at the moment. Yeah, it's I think it was around 2.5 meg or so. The .NET one, so with Blazor, it's a slightly more complex application. It's got some more dependencies in it, and that was 5+ megabytes. And if you look at the network tab, there's dozens of DLLs that get downloaded. So they can be quite large. And then obviously the more code that you've got, the bigger it can become. Golang, you can simplify and strip down smaller with TinyGo. So you can go from megabytes to hundreds of kilobytes, but then it's kind of equatable to a large JavaScript dependency. But that's just the price that you pay for these higher level languages and taking on niceties like garbage collection and memory management. languages where you have to do your own memory management, C, C++, and Rust, they will compile down a lot smaller. So you can get Rust, like Hello World is, I think we're talking like a kilobyte of size, or something like pretty irrelevantly small in terms of what we deploy to the web these days. But yeah, I don't have a good answer because it's really going to depend on the kinds of projects that you're trying to build and the platform that you're building from.
Any other questions? No? If not, then my cat is going crazy. Sorry. So thanks a lot about sharing today, and it was really good.
My pleasure. I'll work out some way to share these slides if people want these slides. Is the best place just on the GitHub issue, or shall I put them on the YouTube live stream chat?
You can also put it on the GitHub issue.
Yep. Cool.
And, yeah, maybe YouTube.
Yep, I will do that.
If we need to find you and ask more questions, Aaron, are you on Twitter? Is
yes.
that the place to go?
Yes, I am. Actually, let me just I'll quickly reshare my screen and go back to the slide with all my information. There it is. Where did Zoom go? Zoom goes there. Whoops, got to hit share. That's where you can find me online.
Nice. Okay, thank you.
And yeah, that's my website and email. Happy to field questions where I can. And if I can't answer them, I will try and find someone else that can. I'll just pass them off to Sarah. Sarah can answer them for me.
Okay.
I'm seeing if she's actually listening still.
Yes, I'm listening to it. I'm in here.
Sorry. So if there are no other questions, does anyone have anything to ask or announce or say on open mic? You can quickly take a few. If you're speaking and haven't unmute yourself, maybe you should unmute yourself. But otherwise, I guess nobody else has. Oh, okay.
Sorry. Quick announcement. Hi, Hui Jie here.
Oh, we can probably start the live stream also already.
Oh. Okay.
Yeah.
Right. Yeah. So yeah, I'm